Hello everyone and welcome back. So in the last video we learned why we need approximate integration. Okay, so basically we need approximate integration because there are some functions in the world where it's impossible to find antiderivatives, right? Okay, so we need to find a different way to solve this definite integral. Basically we want to estimate it, right? Now, if you're going to estimate this definite integral, think about this. Once you solve a definite integral, you should get a number, right? Think about it. You always get a number, not a function. I'm talking about a definite integral. Now, to find a new method, you have to understand what does this number represent. What is definite integral? Can we visualize it? What is the geometric meaning or what does it mean to take the definite integral of a function? So if you can visualize it, then probably we can find an alternate method, right? So that's what we are going to do. So what is really definite integral? So what is that number represent? So let's think about positive functions. Let's confine ourselves for positive functions. So let me draw a positive function. This is f and let's say it's going from a to b. Okay, now what does it mean it to take the definite integral of f from a to b? Can we picture it? Well, what it means is that it is the area under the curve f bounded by x-axis. That means this area. So that number you get from the definite integral is actually area for a positive function f. It is the area between the curve and the x-axis. Okay? Geometric meaning of the definite integral is then actually area, right? Area under the curve. That's perfect. Now what we can do is we can find an alternative method to estimate the area. Okay, now why do we need to estimate the area? Think about this. Think about this function x square. Now you want to integrate, you want to find the definite integral of x square from 2 to 8. Now you have this function x square from blue color and it's going from 2 to 8. So basically it's this yellow color region. Solving this definite integral, the number that you get from here is actually the area of this yellow color region, right? Look at this yellow color region. Is it a polygon? No, right? There's no formula that you can use to calculate this area, right? So probably we have to estimate it. So we are going to use a geometric method to estimate that area. And that geometric method is approximate integration. Alright, now we still have a problem because I was only talking about positive functions. So I said f is positive. Now how about if you have a function where it's not necessarily positive all the time, like sin x. You can see some function values are negative. Now what does it mean to take the definite integral of a non-positive function, of a general function? Well, it will give you the net area. What is net area? Well, for the area that's above x-axis, you add them. Area under the x-axis, below the x-axis, you subtract them. So solving this integral, okay, taking the definite integral of sin x from 0 to 2 pi is actually you add the area from blue color region R1 and then you subtract the area from red color region. So R1 minus R2. Okay, so whatever below the x-axis you subtract that area, above x-axis you add it. So that's the net area. Now the big idea here is that if you integrate a general function, if you take the definite integral of a general function, it gives you net area. So we can still stick with that idea to find an alternative method to estimate the net area. Okay, so it's still valid. Now here's something extra. Now if you look at this picture, probably if you look at the blue color region and the red color region, it seems to be like they are equal, right? So if you subtract the two areas, you should get 0, right? Because this area is equal to this area. So basically when you subtract them, you're gonna get 0. Let's test it. Because sine x, you know the antiderivative of sine x, right? Antiderivative of sine x is negative cosine x. Now if you evaluate it from 0 to 2 pi, so it's negative cosine 2 pi, subtract minus cosine 0, right? Cosine 2 pi is 1, so it's negative 1 here, minus cosine, minus cosine 0 is 1, so minus plus, negative 1 plus 1 is 0, so yes, it's true. The net area is true, okay? Alright, fantastic. So what is approximate integration again? A geometrical method to estimate the area, okay? Because definite integral will give you the net area. Perfect. Now how are we going to estimate it? Let me show you a picture. So the idea here is to find the area of this yellow color region, right? For example, in this example problem. Now what we are going to do is we are going to estimate it using rectangles. Why rectangles? Well, we know how to find the area of rectangles. It's length times width. And we don't need to get the exact answer, right? Because this is an estimation method. There is an error. As long as the error is small, we are fine, right? Now look at this picture. You want to find the area of this yellow color region. We covered the yellow color region best we can by using these rectangles. So instead of finding the area of this yellow color region, now I will find the area of each of these rectangle, and I will add the area of this. How many rectangles we have? I will add the area of these 9 rectangles. Then we can get an estimation of this yellow color region, area for the yellow color region. Probably if you look closely, you can see the area of these rectangles probably is going to be higher than the actual area, because you can see there's a part popping out of the graph from this each rectangle. But as I said before, this is an estimation, okay? So we are not going to find the area exactly, but as long as it's close enough, that's fine. So the basic idea of approximate integration is that you're going to cover the region that you're going to find the area by rectangles. Then you're going to find the area of this each rectangle that you use, and you're going to add them up. So that's the basic idea of approximate integration. Okay, and let me add one more thing. We're going to discuss about this in a broad sense. I mean, this looks like a horrible estimation, right, for our eye. But if we can have more and more rectangles, I mean, there's only 9 rectangles here. If we make its width so small, and if we try to have lots of rectangles, now these are not the most beautiful rectangles, but if you're going to have lots of rectangles, probably we can get a better estimation. But that's something for future. What you want to take away from this video is that finding the definite integral of a function is same as finding the net area. So let's try to estimate the net area. The way we are going to estimate the net area is that we are going to cover up the whole region that we want to find the area by rectangles. Then we find the area of each of these rectangles. Then we add it. Then we can get an estimation of the definite integral, estimation of the net area. Okay. All right. So that's the idea. Thank you very much for watching this video, and let's extend our discussion in the next video.